Hey, Mr. Sams, how you doing?
Not too shabby.
What are you doing? Oh, you're making a mess.
Sorry, it's my desk. It's
Yeah,
all right.
that's true.
You're
drinking some 7-Up, I see.
Yeah.
That's interesting.
Ooh, it's diet.
Diet. Woo!
Oh, I hate diet soda.
Why did you buy the diet?
I don't. You did. It was for our workshop last week.
Oh, yeah, well, I didn't drink it. I don't drink the soda. I just buy the soda. Hey, today we're going to learn about electrochemistry.
Yeah.
Now what are you doing, Mr. Sams?
Well, that's why I'm having a soda.
You're having a soda? Now I wonder if people can see what you're doing.
Maybe.
What are you doing there? Oh, it's like an experiment.
It is. Look
Check
at that.
it out. We have an experiment, people.
So I
Mr.
got my...
Sams has an experiment. Electrochemistry has to do with like electrons.
It does, yeah.
And like electricity.
Moving. And if I get enough electricity, I can make my clock work here.
You have a clock.
Yep. No, it's not working right now.
Mr. Sams, I thought you said it was going to work.
It will. Well, I've got
a
little copper electrode here. Okay.
Yeah.
And I've got a zinc one here.
I see that.
Okay.
Yeah.
But the problem is these two cells aren't really linked to one another, so I'm actually going to take some more copper.
Oh,
some more zinc.
yes.
We're going to go the other direction.
We call that in chemistry land, folks, a salt bridge.
Yeah.
And guess what? I believe it's 2 o'clock.
Is it?
Or noon o'clock.
Noon o'clock. Look at that. My clock works. Can you see
made
that?
a clock.
Isn't it amazing?
He's amazing. A
Yeah.
clock with some soda.
Yep.
So you can get electricity out of a can of soda?
Yeah, well, we're not really getting it out of the can. What we're really getting it out of is these little metals right here.
Oh.
Because what's happening is we have a redox reaction going on.
That's right.
And as a result, there's some electrons that are moving, because on redox reactions, there's always an exchange of some electrons. Something is being oxidized and something is being reduced. So either the copper is being oxidized and the zinc is being reduced, or the copper is being reduced and the zinc is being oxidized.
That's right. And so we're going to have to figure that out as we go, folks. And so we will. So today, we want to do a little bit of review of redox, because something that Mr. Sams just mentioned as you watch the podcast or watch the demonstration was that electrons are moving around, and because it's a redox reaction, and if we can harness those electrons, we have electrochemistry. Electrochemistry.
I still have a really gross taste in my mouth from that diet.
You picked the wrong one. Okay.
Yeah.
Hey, let's just do a real quick review. We learned a long time ago about oxidation numbers, and we need to kind of do a little review.
Yep.
So, what are the oxidation numbers of H, N, and O and HNO3?
Well, I know H's are almost always +1, unless it's a hydride, which is very rare. And oxygen's almost always -2. Now, we also have 3 of them there, so that's going to be -6. And they always have to add up to 0 in a neutral compound.
Therefore?
So it's looking like X is going to be +5.
Same thing, and then this one...
And that would be nitrogen, by the way, the X.
Oh yeah, X equals the charge of the nitrogen. And you would say N +5, O -2, and H +1. So they would each have a different oxidation number.
There you
go. We can do lead sulfate as well.
Yeah.
Now, actually, the hard one will be which?
Well, if I look at this, this is lead 2 sulfate, because sulfate is a -2 charge always, and so lead's going to be +2.
So PB is +2, and we know O's charge is -2.
And
so the only one that's mystery is kind of that S.
Yeah.
Right?
And
so that'll be 2 plus what? X plus -8 equals 0.
And it's -8 because there's 4 of the oxygens.
So S is +6.
6, yeah.
Now, I'm not going to do big math, folks. You can do that. You know what? I think you could figure this one out.
Yeah.
We're not going to do it.
No.
All right. Hey, just remember how we balance oxidation reduction reactions.
Yep.
Just a little deal. Do by the
half reaction method.
Half reaction method. So I'm going to take the aluminum. I'm going to have the aluminum go to aluminum plus 3. And that's 3 electrons on the other side.
I'm gonna have to take your word for it that that's what that says, because I just had I had an eye exam.
It says it, yeah.
And my eyes are all dilated, my pupils are dilated, and everything's all blurry. So.
Well, you could look at that thing there, and we could like bring that back, and we could look at your eyeballs.
That's true. Are they big? Can you
tell?
Oh
my gosh! So the permanganate.
You got a new toy. Can you tell?
Goes to Mn +2. Now you balance your waters or your oxygens with water.
With water, so we need 4 H2Os.
Waters. Yep. And then on the other side, I have to do the 8 hydrogens.
Uh-huh.
And then when you say this side here is +2, this side is +7.
So we need
5 electrons. That's a 7. Doesn't look like 7.
Yeah.
All right, and multiply this one by 5. And this one by 3. So it'll be 5 Als plus 24 H positives. I guess I should say Al.
Al, there you go.
Plus 3 permanganates makes 3 Mn2 positives plus 12 waters.
Yep.
I got some alumins left.
And 5 Al3 positives.
5 Al3 positives.
There you go.
Okay.
Okay.
Now in a basic medium,
solution.
Same ball game.
Yep, to start with.
This is a good one here, this first one. Mg goes to MgOH2. Now on this one, since it's in a basic medium, we actually can just say, well, that's hydroxides here.
Yeah.
And there's like 2 of them.
Yeah.
Done. Oh, is it done?
No.
Charge issue.
Yeah, charge issue.
Got to bounce the charge. Lee, are you balancing the charge?
I don't know. Check.
All right.
2 electrons.
Check
There you go.
there, Lee. Okay. And then we've got the OCl negative, and that goes to Cl negative. Now my Cl's are good.
Yeah.
So now I'm going to balance the O's with water. And I'm going to have to put 2H positive on this side.
Yep.
But of course we're not in an acidic solution, so we're in a basic solution. So I'm going to add
2 hydroxides to both sides to get rid of those H pluses. And the H plus and the OH minus, those become 2 waters.
This is 2 waters.
Okay.
And the
now
1 water here cancels off the 2 waters to make
1
water on that side.
Yep. And we've got some charge.
Charge issue. This side has a charge of -1, OCl negative. This is -3, so I'm going to need an additional 2 electrons on that side. And oh my.
Oh, 2 electrons and 2 electrons.
I got lucky on that one, didn't I?
Yes, you
Now we do have an
did.
issue here, is we have 2 hydroxides on this side and 2 hydroxides on this side, so they just go away.
Bye-bye.
Okay. And anything else canceling? I think we're good. The
yeah.
waters.
The electrons
no, I think
always
we're
know.
just good. So it'll be Mg plus OCl negative
Yep. Plus H2O.
plus 1 water makes the MgOH2 plus the chloride.
Yeah.
Bingo.
So if I put magnesium metal in bleach, I get magnesium hydroxide and chloride on it?
Yes, you do.
Cool. Balance the following redox reaction, the big nasty problem.
You know what? You have big nasty problems in the answers or in the podcasts, and I did an answer podcast for that, so you guys can figure this out on your own. Okay.
Yeehaw, we're going to save your time here.
Okay. Review of redox reaction. What's oxidation?
That's when your oxidation state goes up.
So oxidation
It becomes more positive, I guess I could say.
goes up
Yep, and you lose electrons. That's how that happens.
by losing electrons.
Yep.
And reduction is when
Oxidation state goes down by gaining electrons.
All right, how do you make a, here's a fancy word here, folks. How do I make a battery?
Don't
Now,
you just go to the
scientists-
store and buy them?
You could, but
Yeah.
you know, batteries, we made a battery just a little bit ago. That's your clock.
Oh, that's right.
All right, so if you want to look at a battery, Mr. Sams is now looking at a battery.
Yeah.
See the battery. All right, but
it's
scientists
amazing.
don't use the term batteries. They
No.
call them
Galvanic cells. 'Cause that's
which
what
are a battery. Actually, that's as I wanted to say.
Yep.
This was supposed to say galvanic here, and this is a cell.
we just don't remember what our notes
Yeah,
are supposed to
and
do.
that is a
That's
battery.
okay.
So we can make batteries, folks. And you see, batteries are simply a mixture of chemicals.
We can make them with the disgusting diet soda.
Yes, indeed. Or you know, we can even make it with an orange.
We could make it with an orange. Just stick it in there.
Okay. Now, if you
right.
think about this, actually, let's go back a piece to one of these reactions that we just did. Let's do the easy one here. Well, it's not easy. But here we had electrons.
Mm-hmm.
And maybe we should say one other thing here. I got it now.
All right.
You see, when you have one of these reactions where electrons are, something you may not know, and I want you to write this down, I don't think we put this in the notes, is that, what is electricity?
Electricity is just moving electrons.
That's the key thing. Electricity is moving electrons.
Yep.
And so if somehow we can capture, so when we have a redox reaction, you know, on one side I produce 3 electrons, in the other half reactions I have 3 electrons. If somehow I could have these electrons travel through something,
Like a clock.
like a wire or whatever, you can have the electrons do some work for you,
Yeah.
like make the clock work,
Exactly.
or something of that nature. And so I want you to understand that electricity is simply moving electrons. Everybody look at the light bulb that is probably on in the room that you're at. Realize that electrons are actually moving through wires, and it's doing some work and producing light. Conversely, you're watching an iPod or you're on your computer or whatever. Electrons are moving through your computer, or your iPod, or whatever it might be, and it's doing work. It's producing light. It's also being converted to sound, etc. And so that's how this all works.